We've been looking at evaluating functions at certain values, and evaluating these functions can come in very handy when we're dealing with something called the difference quotient. Difference implies that we're dealing with subtraction, and quotient implies that we're dealing with division. Well, where we're going to apply this is specifically in dealing with points. We know that if we have 2 points on a graph, we can use those 2 points to find the slope. Note on a graph that the y values can also be defined as f of x values. Remember, f of x is just a fancy way of saying y. To determine the slope, we can simply do y2 minus y1 over x2 minus x1, but using the values of functions, we can rewrite this as f of x2 minus f of x1 divided by x2 minus x1. Again, these are just fancy ways of saying y2 and y1. Notice this helps us when we're dealing with functional notation now. So for example, if our function has a specific value of 8 minus x squared, we want to find the difference quotient. To do that, we're going to find f of 5, which just means we're going to take that function and plug in 5 everywhere we see an x. F of 5 will be 8 minus 5 squared minus 8 minus 3 squared for f of 3 divided by 5 minus 3. This gives us 8 minus 25, which is negative 17, minus 8 minus 9, which is negative 1, all over 5 minus 3, which is 2. Negative 17 minus negative 1 becomes plus a positive, or 16 over 2, which is negative 16 over 2, which is negative 8. If we look at that in terms of a graphic picture here, remember, these are y2 and y1, x2 and x1. We can label our points here and see that we have, in this case, x2 is 5. So x2 and y2, x1 and y1 allows us to calculate the slope of the line here. We can think of this in even further terms with the change in x and the change of y for any 2 points on the graph. So in other words, if we want to find delta y, which is the change in y for these 2 points, these are the y values in the function, then we're going to do f of a plus h, that's the second y value, minus f of a. Using the function as was defined above as the 8 minus x squared, we're going to do 8 minus a plus h squared minus 8 minus a squared. I'm just plugging these values into the function. This gives us 8 minus, when we FOIL this, a squared plus 2ah plus h squared minus 8 plus a squared. As I distribute the negative, I get 8 minus a squared minus 2ah minus h squared minus 8 plus a squared. Notice several things cancel here, and I'm left with negative 2ah minus h squared. This is the equivalent for the change in y for any 2 points on this graph. Now, if I want to calculate delta x for these points that I've already listed, again, this being an x and this being an x, my delta x can be calculated as x2 minus x1, or in this case, a plus h, this being x2 minus a, which results in h. Now, to find the slope, we've defined slope as the change in y over the change in x. Here was our change in y, negative 2ah minus h squared, over the change in x, which we calculated to be h, Notice everything has an h that can cancel. And so we're left with the slope is -2a minus h.